Week 1 videos continued, and this is an introduction to factoring. We're going to introduce factoring to you by doing more practice on multiplying monomials times polynomials and binomials times binomials. And hopefully this extra practice will give you an idea what's going to happen with factoring in the next video. So let's get started with our first example. We have a monomial outside of parentheses, and since there's no plus or minus sign in between that clump and the parentheses, I know there's invisible multiplication here. So the 6x squared wants to get multiplied by everybody in the parentheses. So I like to draw those arrows to remind myself, and sometimes we put a times sign on top so that we don't forget and start adding things. We are multiplying. Okay, so 6 times the 2 gives me 12, so multiply your numbers first. And x squared times x squared, that's x times x times x times x. That's x to the 4th, or take the shortcut and just add the exponents. Alright, next I'm going to be doing a positive 6 times a positive 4. So I can put a plus sign here right away because I know the answer is going to be positive. 6 times 4 is 24. And x squared times a plain x, remember you can always put a 1 there, so a 2 and a 1 make 3, or think x times x times x is x to the 3rd power. Alright, last but not least, 6x squared times a minus 5. Positive times a, think of it as negative, is going to be subtract or negative. So 6 times 5 is 30. There's no variables to multiply here by the x squared, so we just write the x squared down. Now I look to see if there's any like terms. Nope, everybody's variable has a different exponent, and I am done. Alright, more practice with multiplying two binomials. I'll do it with the FOIL method first, and then I'll find a separate sheet of paper and do it with the box method. So watch or do both methods and then decide which one you like better. Alright, for FOIL, I multiply the first. So remember, everybody over here wants to get multiplied by everybody over here. So I'm multiplying my firsts. X times x is x squared. Now I'm multiplying the outers, timesing the outers. X times, think of that as negative 4, or subtract 4. And so I'm going to write the subtraction down, and I get 4x. Okay, really pay attention to signs. A positive 1x times a minus 4, minus 4x. Alright, next I go to I, FOIL, F-O-I, the inners. Because x multiplied by everybody next door, now 7 needs to. 7 times x, so I'm multiplying my inners, equals a positive 7x. Positive sign in front of the 7, no sign in front of the x means plus 7x. And last but not least, 7 gets multiplied by that negative 4. 7 times negative 4, or subtract 28. Now, as usual, the two inner terms can be combined. Remember how when we're combining like terms, we circle the sign in front of them? So I will have x squared, a negative 4 and a positive 7, make a positive 3x, and a minus 28. And we are done. So we'll take a second to go to a separate sheet of paper for those of you that want to learn the box method and continue to use it. Let's take that same example. I just don't have enough room here. So this is example 2 from Factoring Introduction, and I'm going to set it up. It's x plus 7 times x minus 4. I'm going to set it up with the box method for those of you that like that method. So we need a 2 by 2 square, and along the side I'll put my first binomial. It doesn't really matter, x and 7. Since it's positive plus 7, I don't need to write a minus sign in front of that 7. Sorry, you didn't see that. And then along the top I'll write my x and a minus 4. See how I do that? Because it's subtract 4, I need to make that a negative 4. Now I multiply the side of this box by the side of this box. 7 times x is 7x. I multiply the side of this box times the side of this box right here. This one times this one. Well, this side's the same length as that one, so this is also x. You can write it there if you need to. X times x is x squared. Alright, this one times this one, or this side of the box times this side of the box. Since this is 7, this is also 7, and we get negative 28, negative 4 times 7. And finally, this side of the box, or here times here, here times here, however you want to think of that. Since this is negative 4, this is also negative 4, and this is x, since this is also x. So I've got negative 4 times x goes here, or you can think of it as negative 4 times x. Either way, we get negative 4x. Now I kind of set this one up a little bit differently than the example in the last video, but basically I've got like terms on one of my diagonals. Last time I had them here, but they'll show up in either place. And these can now be added together or combined. 7x minus 4x is 3x. Now let's collect all our terms. We've got the x squared from that corner. We've got the 3x from the diagonal by adding those two up, and we've got the minus 28. So we got exactly the same answer that we got when we use FOIL. Again, you decide which method you like better. Alright, let's do our last example in multiplying binomials. We've got 3x plus 5 times 3x minus 5. Now this one is going to be interesting because it's exactly the same terms in each binomial. A 3x here, a 3x here, a 5 here, and a 5 here. But the difference is one is being added, one's being subtracted. So let's see what happens when we have this special situation. Alright, 3x times 3x is 3x squared. There's my first. My outers, 3x times, watch it, that's a minus 5. So that'll be negative 15x. 3 times the negative 5 is negative 15. Bring x along for the ride. Alright, then we multiply the inners. 5 times 3x, both are positive, so we get plus 15x. Interesting. And then finally my last, we have a positive 5 times a negative 5. Plus 5 times minus 5 is negative 25. A positive times a negative. Now look at our inner two terms this time. This one and this one. Remember, there's usually two like terms to combine in these. We have a negative 15x and a positive 15x. What happens when you add opposites together? Well, you get 0. They will actually cancel each other out. And all we're going to have left is 3x squared minus 25. This is the only problem so far. If you look at this one, and you look at this one, and you look at now this one. This is the only one where we end up with just two terms. And it's because of this special situation that we call, what do we call this one? Difference of perfect squares. Where we have something plus something in the first binomial, and then those two same things again in the second one, but a plus sign here and a minus sign here. It will always turn out so you'll have the first thing squared minus the second thing squared, just like what happened here. The first thing squared, 3x squared. Oh, by the way, I didn't do that right. That should be 9x squared. I goofed up. 3 times 3 is 9. Did you catch that? I hope you did. Go back and fix that. Alright, so we end up with the first term squared minus the second term squared, and the two inner terms drop out. We'll do one more example, and this is because you will run across this particular one in your homework, but we don't have it in our video so far. What if we have this? X plus 3